It may be the size of a quarter, but researchers have high hopes for this little robot.
Here we're building some robo-bees who could utilize colony techniques and perhaps go out and pollinate large swarms of crops. You could also imagine search and rescue, an environment that people couldn't or shouldn't go into. Perhaps a robo-bee could go in and assess damage, look for survivors in an accident, things like that.
You heard that right. Robo-bees, as in robotic bees. A result of the partnership between Harvard School of Engineering and the Wyss Institute, researchers are trying to solve real-world problems with biologically inspired insect-like robots.
There's many aspects of natural systems that we use to inspire our work for the flight mechanism. So we take a lot of inspiration from flies, actually, where flies have two wings. They have certain degrees of freedom of the wings. Working with our biologist colleagues, they said, okay, these are the important aspects of this, and that gave us a guideline. So two wings moving with these 2 degrees of freedom, almost doing this sort of treading water-like motion in air. It's sort of just a trick that we can do is very difficult engineering problems. Well, let's see if there's a biological analog and use that to give us a shortcut.
The toughest engineering problem? Creating something so precise in an affordable way. The solution looks a lot like a pop-up book.
A person doesn't have to manually put these things together. Through a combination of linkages and adhesives, we can have something that folds itself into position using almost an origami technique, and do it with a single degree of freedom, just like on this big sample right here. So as the two plates pull apart, you can see that the robo-bee actually folds its way right into position. So we can come out with masses of these things that are less expensive, and we could deploy them into the field. If half of them don't come back, that's fine.
But first, they have to be ready to leave the lab, and that includes some big stumbling blocks.
Other challenges currently now are power. How do we actually get power on board the devices, make them autonomous? How do we think about what sensor information is going to be required for them to fly around? How are they going to compute? How are they going to reason about their environments? Those are the biggest challenges right now.
So while you won't be seeing these bees at your next picnic, there's hope yet that the developments in the lab could cook up a long-term solution.
Perhaps there's a technological assistance while colony collapse disorder is rooted out and solved. Maybe these bees could fly around and do some pollination. Now, mind you, though, this is 20, 30 years down the road. We're really focusing on some of the basic technologies and the basic science right now.
Matt Stewart, CNN Money, New York.